So another topic, well, these are going to be a little bit different. It says solving a 3 by 3 system of linear equation that is inconsistent, no solution, or consistent dependent. That means infinitely many solution. And I guess the inconsistent, these ones are going to be easy. I'll go ahead and write that down. Inconsistent, this is going to be just no solution. Everything cancels out and you get this awkward false statement. Then you're going to say no solution. That's going to be an easier one. But the ones that are consistent in a dependent, these are the ones that has infinitely many solutions. And in class today, we talked about how to come up with a general solution. Because it says infinitely many solution, not anything. We're not talking about every possible pair of order triple. It has to meet a certain condition. So inconsistent ones are going to be easy because you can just say no solution and move on. But if it's consistent dependent, infinitely many solution, we're going to look at how to write a general solution set. I can't remember which one example one is, but let's go ahead and get started on this. So first, we have to look at the big picture. I'm looking at these 3 equations. You notice anything? I noticed something, you guys. I want to cancel out stuff, right? So I want to have some opposites. Like they look exactly the same except for the sign. And I noticed this. Look, there is a positive z. What's that dotted? There is a positive z and there's a negative z. So if I add equation 1, just call it, this is my notation of equation 1, okay? And equation 2 together, those two together, the z will cancel out, right? And that's what I want. I'm going to go ahead and start with that. So here's my plan. Plan number 1, I will add equation 1 with equation 2. Cancel. Oh, you know what? I have a better word. How about we say eliminate? Eliminate z. Okay. So here's equation 1. Negative x plus 2y plus z equals 1. That's equation 1. And let's write down the second equation right underneath it. Minus y minus c equals 3. And we're going to add these two vertically, okay? We're going to add these two vertically. If I do that, all right, first term, negative x plus negative 2x. That is negative 3x. All right, next, 2y plus negative y. That's just 2 minus 1. That is plus y. And this is why we are doing this. Look at this part. Z plus negative z, they cancel out. So no more z. No more z. All that equals 1 plus 3, which is 4. Whoopsies, which is 4. So we just came up with, let me call this equation number 4, okay? So this is equation number 4. Just going to name this. I'll call it EQ number 4. Okay? What I need is another, one of these equations that doesn't have z. You see, equation number 4 has only x and y in it, right? There's no z. So my second goal is I want to use the third equation, you see? The third one that we didn't even use. And I want to cancel out z there, just like how equation 4 doesn't have z. So what can I do? Focus on the z here. This is negative 3z. How do you cancel out negative 3? You need a positive 3, right? So I have an idea. I can multiply this positive z by 3 so that I have 3z and negative 3z. Those will cancel out. So here's my plan, and I'm going to go ahead and write this down so that you can see where I'm going with this. Number 2, multiply equation number 1 by 3 and add with equation 3. And why am I doing that? To eliminate negative 3z. That's my plan. Okay, so take a look. I need to do my multiplication now. I'm going to multiply the top equation by 3. All of them will get multiplied by 3. So that will be negative 3x plus 6y plus 3z equals 3. So this is equation number 1 multiplied by 3. So what I did was I just distributed that 3 to these 4 terms. That's what got me this. I hope you're okay there. Okay, what's next? I'm going to just go ahead and write down equation number 3 in the bottom of this, okay? Equation number 3 is this. I'll go ahead and write that underneath it immediately. Negative 3x minus 4y minus 3z equals 5. And I'm going to add these two together, okay? I will add these two vertically together. All right, let's combine the like terms. If I add negative 3x and negative 3x, that's going to be negative 6x. They're not opposite, so they add up to negative 6. Next term, if I do 6y plus negative 4y, 6 minus 4 is 2. So I'm going to get plus 2y. And what happened? This is what we really wanted. The 3z and negative 3z, they cancel out. So no more z right there. So that's gone now. And this equals, add the numbers on the right side. 3 plus 5 is 8 there. So what we just did was we created another equation. And this guy, let's call this equation number 5. We just came up with equation number 5. And what we are going to do now is we're going to work with those two equations that we just came up with. Equation 4 and equation 5. Why? If you're like, why are you working with those? Because they both are missing variable z. So I'm going to go ahead and circle this. I'll work with this. And I'll work with this. I'm going to put them together as a single system. Okay, I'm going to come up with another system putting those two together. So here is number 3, step number 3, working with negative 3x plus y equals 4. You know where I got that from, right? Right here. And right underneath it, let me go ahead and write down negative 6x plus 2y equals 8. Okay, this is the 5th equation that we just came up with. And I'm going to try to solve this system now. Let's solve this system. This is equation 4. And this is equation 5. Oh no, I noticed something here. Okay, as we are trying to solve this, I wonder if you noticed this. I'm going to multiply equation number 4 by 2. I think you'll see it. Okay, take a look. If we double every term here, let's double everything here. Multiply everything by 2. That's going to be negative 6x plus 2y equals 4. I'm sorry, 8. right? If you double everything in that red boxed equation, it's going to be that. Right underneath it, I'm going to write down equation number 5. Negative 6x plus 2y equals 8. This is equation number 5. And above here is 2 times equation 4. You see what's happening here? These two equations are exactly the same. Do you see that, right? So what does that mean? If I add them vertically, let's add them vertically. Okay, if I add them vertically, I will get, no, I'm not going to add them, I'm going to subtract them. I'm going to subtract them. That's better. Subtracting means I'm going to do negative 6x minus negative 6x, right? So whenever we subtract, we can change the sign of the second polynomial here. So what's going to happen is I will have this to be a positive sign, this to be a negative sign, and this will be a minus sign. What's happening? The sign of the second term will change. Or you can just think of it as subtracting, that's okay. So if you do negative 6x minus negative 6x, you know, anything subtracted by itself is 0, right? So that's 0. 2i minus 2y, that's another 0. 8 minus 8 is 0. So we got 0 equals 0. This is a true statement. So what kind of system is this? This system is consistent. Remember from going over something like this with 2 by 2 during class today. This system is consistent, dependent, with how many solutions? With infinitely many solutions. Because it has infinitely many solutions, we better give them how to write a general solution. Okay? So hold on, let me zoom out. I'm about to add another page so that we can work on writing the general solution of this. Because having infinitely many solutions does not mean anything can be an answer, right? So let's see, what do I have here? I'm going to borrow equation 4. It's because this is pretty simple. You see how simple it is? It's like negative 3x plus 4, y equals 4. If I kind of add 3x to both sides, what will I have? I will get y equals, I'll go ahead and write it down there. Hold on, let me copy this. This is equation number 4. I'll copy this and I'll move it down here. It's a long problem it is. This is equation 4. If I move the 3x to the right side, right, we can do that. Then what we will get is y equals 3x plus 4. So you see what I'm trying to do is I'm trying to write y and z in terms of x. So that what we can say is, hey, if x is this number, to find y, you plug it into this expression. To find z, you plug it into this equation. So far, I can write what y is using the variable x. So when I'm writing my solution, hold on, and I may have to write my solution in the bottom there. Oopsie, this picture didn't follow me. Okay, when I'm writing my solution, I will have, all the way in the bottom here, x for the first position. X can be anything I'm saying, but y has to be 3x plus 4. Whatever x is, to find the y value, I will multiply that x by 3 and add 4. That's what I mean by 3x plus 4 there. Now, I need to do the same thing, similar thing for z. I need to do the similar thing for z. Okay, so let's go up and find an equation that we can use to find z. Where is z? There are not too many. Because we canceled out z in the very beginning. So, hey, I'll go work with equation 1. Why? Because that's the one with the very good looking z. It just says z here. Okay, so I'll copy this. I will copy equation number 1. I copied it, and I'm going to bring it down right here. So this was equation 1. I'm going to plug in what y is in here. Y is 3x plus 4. So this y can go right in here. Okay? So what's that going to be? Negative x plus 2 times 3x plus 4. That's what y is, right? Plus z equals 1. I'm solving this for y. And solve for, I'm sorry, I said y. Solve for z. We already have something for y. We're solving this for z. Okay, so if I distribute this 2, that will be negative x plus 6x plus 8 plus z equals 1. And what I'm going to do is I'm going to move everything else to the right side. All of these can go to the right side. All of they can go to the right side. So that I can finally have just z alone. Z equals positive x minus 6x minus 8 plus 1. Now let me combine the like terms here. 1x minus 6x is negative 5x, and negative 8 plus 1 is negative 7. So we did it. Z is negative 5x plus 7. So when they are writing those general solutions, I can tell them just pick on x and multiply that by negative 5 and subtract 7. That is how they can find the corresponding z value. So this part was, I think, probably new. But try it. It's just a matter of solving for the variable in terms of one of the letter. Because as you can see, the only variable that we have is x. If you just pick on x, you can use that x to talk about y. You'll do 3 times that x plus 4, and that's going to be the y value. And you can do negative 5 times that x value and subtract 7. That will be the corresponding z value. So if it has infinitely many solutions, you guys, then you will have to write them a general solution. So I'm going to go ahead and give it a title over here. Here is to find general solution x, just to say general solution. And I just picked x, but you could have easily picked y or z to be your initial or starting variable. But since x is very oftentimes the input variable, I decided to just use x as the only letter in this general solution. But that is it for this example. I think this one was a little bit challenging. Okay, but I will come back and go over a case where it comes out to be no solution in just a second.